Hello everyone. In today's lecture, we go with the concept of the application of matrices for solving a system of linear equations. This is the very important part in our syllabus in this chapter. By using this concept, we find or we solve the linear equations, and to solve this we use matrix. Okay, so before go with this concept, firstly we go with here how to convert given linear equation in the matrix equation. Okay, for this we consider here two equation. Here first is a1x plus b1y is equal to c1, and second is here a2x plus b2y is equal to c2. We consider these two linear equations, okay, and we have to convert this equation in the form of matrix equation. So we can write this as, here I write this as, here inside the matrix, here in LHS given a1x plus b1y, then here in the second equation given here a2x plus b2y, and this is equal to here inside the matrix, here I write the constants, here c1 and c2 are the constants. So here in the matrix we consider c1 and c2. Now by using the definition of the multiplication of matrices, here this can be written as, here inside the matrix, here firstly we consider the coefficients of the variables, that is the coefficients of x and y for the first matrix. Okay, here coefficient of x is a1, so I write here a1. Next, here coefficient of y is b1, so in the first row second element is b1. Next, here this here for the second coefficient of x is a2, so in the second row first element is a2. Next, here for y, your coefficient is b2, so second element from second row is b2. So this first matrix is for the coefficients of the variables x and y. Then for the second matrix we consider the variables. In this equation only two variables are given, and here x and y are the variables. So here I write inside the matrix x and y, this is equal to, then here inside the matrix we consider the constants, that is this matrix as it is, here inside the matrix c1 and c2. So remember here by using the definition of multiplication of matrices we write this as like this. Okay, now this is in the form here ax is equal to b. This is in the form ax is equal to b. Try to remember here A is the matrix of the coefficients of the variables. Then here x is for, here x is the column matrix and is for the variables. Next here this b is also column matrix and is for the constants. Okay, now also remember here A is the matrix. If A is the given matrix and is having order 2 by 2, here A is the matrix having order 2 by 2, and here X is the matrix having order 2 by 1. Then here by using the multiplication, here B is the matrix having order 2 by 1. So remember this point also. Okay, so this is for this type of linear equation. If we have three linear equations with three variables, then here I write this as, okay, let us consider the three equations. Here first is a1x plus b1y plus c1z is equal to d1. Then second equation is a2x plus b2y plus c2z is equal to d2. and third equation here a3x plus b3y plus c3z is equal to d3. Okay, here we consider three equations with the three variables. Okay, then here as explained in the beginning, they can be expressed as, again we have to convert this equation in the form of x equal to b. So here I write this as, here in the first matrix we consider the coefficients of the variables x, y and z. Okay, here coefficient of x is a1, then coefficient of y is b1, coefficient of z is c1. This is for the first row. Then for the second row we consider the second equation. Here coefficient of x is a2, coefficient of y is b2, coefficient of z is c2. Then for third row we consider third equation. Here again coefficient of x is a3, for y is b3, for z is c3. So this is the first matrix and is having coefficients of the variables. Then here for the second, here for the x we consider the variables. In this equation three variables are given, x, y and z. So this is the matrix, this is the column matrix, okay, having elements x, y and z. This is equal to, then in the third we consider the constants. Here constants are d1, d2, d3. Okay, so again this is in the form ax is equal to b. Again remember, here A is the matrix of the coefficients of the variables, x is the matrix, x is the column matrix of the variables x, y and z. Then here last is the matrix, B is the matrix of constants and is the column matrix. This A matrix, if A is the matrix having order 3 by 3 and X is the column matrix having order 3 by 1, then here B is the matrix having order 3 by 1. So remember this point also. Okay, so using these equations, we find the values of the variables. The values of the variables x, y or x, y, z as the case may be. So using these equations we solve the system of equation. So we go with our method to solve the system of linear equations, and is here method of inversion. Okay, so we go with our method of inversion. Here we consider method of inversion. Here inversion means we find or we solve this equation by using the inverse of given matrix. So this inversion means here we consider inverse of given matrix. So remember this. Okay, let us consider our equation. Now we know our equation, matrix equation. Here equation is AX is equal to B. This is our equation. We know here if the solution of given equation exists, then matrix A must be non-singular. That is, here A inverse exists. Okay, and we find or we consider to find the A inverse, we use either transformation method or we use adjoint method. We know what is transformation method, we know what is adjoint method. Using these two methods, we find the inverse. Okay, so here to solve this system of linear equation, firstly we multiply the both sides by A inverse. Okay, so here A inverse into AX is equal to here A inverse B. Now I write this as, here I write this as A inverse A into X is equal to A inverse B. We know here A inverse A is the identity matrix. So I write here Ix is equal to A inverse B. Okay, and we know here identity matrix into any matrix is always matrix itself, that is X. This is equal to here A inverse B. Okay, and using this equation, using the equation X is equal to A inverse B, we find the values of the variables. We find the values of the variables. So try to remember this equation. This form is very important. X is equal to A inverse B. So if example is given, if system of linear equation is given, then firstly we find inverse either by using transformation method or by using adjoint method. After finding the A inverse, we replace A inverse and B in this equation and we find the values of the variables. We find values of the variables. So this equation gives the required solution. Okay, so we go with our first example. Here given, solve the following equations. Solve the following equations by inversion method. Okay, here given in first equation is x plus 2y is equal to 2, and second is here 2x plus 3y is equal to 3. Okay, now we have to solve these two equations by using inversion method. Okay, firstly here we write the given equation in the form of matrix equation. Okay, so the given equation can be written as the given equation can be written as okay, so here we consider first matrix. This matrix is having coefficients of the variables. Let's go with our first equation. Here in LHS, coefficient of x is 1, then coefficient of y is 2. So first equation is for first row. Next, here we consider second one. Here for second row we consider the second equation. Here coefficient of x is 2, then coefficient of y is 3. Okay, so this is the given matrix of coefficients of the variables. Then in second matrix we consider the variables. Here variables are x and y. So this is the column matrix having elements x and y. This is equal to here in RHS we consider the column matrix of constants. Here constants are here 2, here for first 2, here for second 3. So we get this form, and we know this is in the form here AX is equal to B. AX is equal to B. Here A is equal to, A is the matrix having elements. If we compare these two, we get matrix A and is having 1, 2, 2, 3. Then X is the second matrix and is having the variables. So inside the matrix we have XY, then B is the next matrix and is having constants. Here constants are 2 and 3. So is the column matrix having elements 2, 3. Okay. Now we consider our given equation. Okay. Here consider here AX is equal to B. We have to create the form to find the or to solve the system of equation, and to solve this we multiply here both sides by A inverse. Okay, so here A inverse into AX is equal to A inverse B. Okay, now I write this as here A inverse A into X is equal to A inverse B. We know here A inverse A is identity matrix, so IX is equal to A inverse B. Again, here we know identity matrix into any matrix is matrix itself, so here X is equal to A inverse B. Here I write in box and we note this as 1. Since after finding the A inverse, we replace this inverse in this first equation to find the values of the variables. Okay, now we consider this matrix A to find the A inverse. Okay, so here now as A is equal to, A is the matrix having elements 1, 2, 2, 3. Okay, firstly we check whether inverse of given matrix exists or not, and to check this we consider determinant of A. Here determinant of A is equal to, we know 1 into 3 is 3 with minus sign. Here 2 into 2 is 4 and this is equal to minus 1. Here we get determinant of A is not equal to 0. If determinant of A is not equal to 0, we say here A inverse exists. A inverse exists. Okay, let's find A inverse. Now to find the A inverse we use either transformation method and or we use here adjoint method. Let us consider the transformation method, and in that we consider the row transformation. If we have to consider a row transformation, we consider the equation A inverse is equal to I. Okay, we replace A by using the elements here 1, 2, 2, 3. Then we keep A inverse as it is. This is equal to identity matrix. If A is having order 2 by 2, then the identity matrix is also having order 2 by 2. So here elements are 1, 0, 0, 1. Okay, now everyone knows the row transformation, or we know the elementary transformation. If we have to use row transformation, here we have to perform the series of row transformations. Okay, so firstly here we want 1 already. Here in the position of A1, 1, we have 1. Okay, so we go with our next step. We have to make this A2, 1 as 0. That is this 2 as 0. And to make this 0, we use here, consider we have to perform transformation on row second, since this 2 is in row second. Okay, and transformation is here R2 minus 2R1. That is, we multiply each element of row first by 2 and we subtract this from elements of row second. Okay, so here inside the matrix, here we keep first row as it is, that is 1, 2 as it is. Now transformation is for row second and transformation is R2 minus 2R1. Here first element from row second is 2, then with minus sign 2 into first element from row first is 1. We know here 2 minus 2 is 0, so here in the position of 2 we get 0. Next, here second element from row second is 3 with minus sign here 2 into. Here second element from row first is 2, okay, and this is equal to, we know 3 minus 4, we know 3 minus 4 is minus 1, so here in the position of 3 we get minus 1, okay. Now in next, here A inverse as it is equal to, we perform the same transformation in RHS. Firstly, we keep first row as it is, that is 1 0 as it is. Then here first element from row second is 0. Then with minus sign, here 2 into first element from row first is 1. So this is equal to, we know 0 minus 2 is minus 2. So here in the position of 0, we get minus 2. Next, for the second position, here second element from the second row is 1. Then with minus sign 2 into, here second element from row first is 0. Okay, this is equal to, here we know 1 minus 0 is 1. So here in the position of 1, we get 1. Okay, here we get 1. Now in the next step, here we make this minus 1 as 1. Since here in the position of A to 2, we have 1. So we make this minus 1 as 1 by using the transformation. And to make this, we multiply here each element of second row by minus 1. Okay, so here okay, here I write here transformation is on row second and transformation is minus 1 into row second, that is we multiply each element of second row by minus 1. So in the next step, here we keep first row as it is. Here in the first row given 1 2, so here 1 2 as it is. Then we multiply second row, each element of the second row by minus 1. We know 0 into minus 1 is 0, so here we have 0. Next, here minus 1 into minus 1 is 1. Okay, so here 1. Then here A inverse is equal to, we perform the same transformation in RHS. Here again we keep first row as it is. Here 1 0 as it is. Next, we multiply each element of the second row by minus 1. We know minus 2 into minus 1 is plus 2. So here we have 2. Then here 1 into minus 1. We know 1 into minus 1 is minus 1. Okay. So we make this minus 1 as 1. Now in the last step, we have to make this A1 2 as 0. That is this 2 as 0. And to make this 0, we consider here R1. That is transformation is on row first and transformation is here R1 minus 2R2. That is we multiply each element of the second row by 2 and we subtract this from our elements of row first. Okay, then we get 2 minus 2. 2 minus 2 is 0. So here, first element from row first is 1 minus 2 into first element from row second is 0 and we get 1 minus 0 and we know this is 1. So here in the position of 1 again we have 1. Next, here second element from the first row is 2. Then with minus sign 2 into, here second element from second row is 1. So here 1, this is equal to, we know 2 minus 2 and is 0. So here in the position of 2 we get 0. Now here we keep second row as it is, that is this 0 1 as it is. Next A inverse is equal to, again we perform the same transformation in RHS. Okay, here first element from first row is 1. Then with minus 2, here first element from row second is 2. So here we have 2 is equal to, we know 1 minus 4. 1 minus 4 is minus 3. So here in the position of 1 we get minus 3. Next, here second element from first row is 0 with minus 2. Here second element from second row is minus 1. So here minus 1 is equal to, we know minus 2 into minus 1 is plus 2. So here in the position of 0 we get 2. And here we keep second row as it is, this 2 minus 1 as it is. So we get form, or here we convert, we reduce this matrix A to identity matrix. Okay, then we get form. Here I A inverse is equal to your matrix having elements minus 3, 2, 2, minus 1. Okay, and lastly here we get A inverse, and here A inverse is equal to inside the matrix minus 3, 2, 2, minus 1. And by using this inverse we find the values of the variables x and y. Okay, so here to find the values of the variables we consider this first equation. Here I write using 1, okay, here we know 1 is x is equal to A inverse B. Okay, so here x is equal to, we know A inverse. Here A inverse is having matrix, okay, and having elements minus 3, 2, 2, minus 1. Then here matrix B is having, here in matrix B we have 2, 3. We have 2, 3. Okay, after solving this multiplication we get values of the variables. Here first matrix is having order 2 by 2. The second matrix is having order 2 by 1. Here we know number of columns from first row and number of rows from second matrix. I repeat again, here number of columns from first matrix and number of rows from second matrix are equal. These two are equal. If these two are equal, here product is conformable. And here new matrix is having order here 2 by 1. New matrix is having order 2 by 1. So remember this. Okay, now we know the matrix having order 2 by 1. We consider the elements here A1, 1 and A2, 1. This matrix is having order 2 by 1, that is having 2 rows and 1 column. Okay, so here for product we consider firstly A11. Here in A11 we consider first row, first column. So here first row and first column. So we multiply our corresponding elements. Here minus 3 into 2 is minus 6 plus 2 into 3 is 6. Now here for A21 we consider second row, first column. That is this second row and this first column. Okay, here again 2 into 2 is 4 plus minus 1 into 3 is minus 3. Then here I write this as, we know this matrix X is having elements XY and this is equal to, here inside the matrix we know minus 6 plus 6 is 0. Then here 4 minus 3 is 1. Now by equality of matrices, here we get X as 0 and Y as 1. So by method of inversion we find values of the variables X and Y. Okay, so this is very important example. Okay, now in today's lecture we see how to convert given linear equations in matrix equation form. Then we see in method of inversion we consider the equation X is equal to A inverse B. Okay, and we see one example for this concept. Okay, in next lecture we see some more important example related with the method of inversion. Thank you.